Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. So in today's video lecture, I am going to discuss about the KVL and KCL problems and dependent source problems. Okay, so here we need to discuss about some problems on KVL and KCL and dependent sources problems. Okay, so here, first the problems on Kirchhoff laws. So basically the statement of Kirchhoff current law is the algebraic sum of the incoming currents is equal to the algebraic sum of the outgoing currents. That is the statement of KCL. Or the algebraic sum of the total currents meeting at a single node point is always equal to 0. That is the another definition of the KCL. Now we are having the Kirchhoff voltage law. So Kirchhoff voltage law is nothing but the algebraic sum of the total voltage drop at each and the voltage drop across each and every element is always equal to 0. That is the statement of KVL. Or we can also say the total voltage is equal to the algebraic sum of the individual voltage drop across each and every element. That is the statement of KVL, right? Now we'll discuss some problems on KVL and KCL by using the independent sources, right? So here, for example, I am taking the one circuit here. So here I am taking the one simple circuit. So I am taking the 3 loop circuit here. So the source voltage I am taking as 20 volt, and this is 1 ohm, and this is 2 ohm, this is 3, 4 and 5 ohm, right? So we are having the 3 loops here, right? So in the given circuit, total number of loops are 3. So the required currents are 3 here. So here this is loop number 1, first loop, and this is loop 2, and this is second loop, and this is third loop. Total 3 loops are there. Now first loop current I am taking as I1, second loop current I am taking as I2, and third loop current I am taking as I3, right? So total we are having the 3 currents, I1, I2 and I3. Okay, so loop current is I1, loop current is I2 and loop current is I3. Now the current to 3 ohm. So the I1 current towards this node point, from this node point the current is downwards. Now the current through 3 ohm is I1 minus I2. Similarly at 4 ohm, so current through 4 ohm is I2 minus I3, right? Here is the current direction. So after that we have to give the current directions. So the current directions is depends on the direction of the current. So here the 3 loops are in clockwise direction. As per the clockwise direction, we have to give the current directions here. We have to assign the polarities here. So here starting from positive, minus, this is plus minus, plus minus, this is plus minus, and this is plus minus, right? Now simplify this equation. Means we need to apply KVL in loop 1, loop 2 and loop 3. Now the first loop equation. So first loop equation, I am starting from this point. So when I am starting from this point, always we need to take the second polarity. So the second polarity is positive. So plus 20. Now at 1 ohm, second polarity is minus. 1 into I1 is I1, and at 3 ohm, second polarity is minus. 3 into I1 minus I2. And here there is no more elements, that should be equal to 0. Now 20 minus I1 minus 3I1 plus 3I2 equal to 0. Now minus I1 minus 3I1 minus 4I1 will go that side. So plus 4I1 minus 3I2 equal to 20. Let us take as equation number 1. Here is the first loop equation, 4I1 minus 3I2 equal to 20. Right? Now similarly, apply KVL in loop 2. So loop 1 is over. Now apply KVL in second loop. Now the second loop equation is, so here I am starting from this point. When I am starting from this point, always we need to take the second polarity. That is minus 2I2 minus 4 into I2 minus I3 plus 3 into I1 minus I2 equal to 0. Right? Now simplify this equation. So minus 2I2 minus 4I2 plus 4I3 plus 3I1 minus 3I2 equal to 0. Now 3I1, so minus 2I2 minus 4I2 minus 6I2 minus 3I2 minus 9I2 plus 4I3 equal to 0. Let us take as equation number 2. Here is the second loop equation, right? Now the third loop equation. So apply KVL in loop 3. So here the third loop equation is, so in this case I am starting from this point, so we can go for the clockwise direction. So I am starting from here. So at 5 ohm the second polarity is minus and the voltage drop is minus 5I3, and here the current is going like this. So at this node point the second polarity is plus. So plus 4 into I2 minus I3, that is equal to 0. Now minus 5I3 plus 4I2 minus 4I3 equal to 0. So 4I2, so minus 5I3 minus 4I3 is minus 9I3 equal to 0. Let us take as equation number 3. Now by solving the equation number 1, equation number 2 and equation number 3, we will get loop currents I1, I2 and I3. So by solving this equation we will get the loop currents I1, I2, I3. Similarly, we can calculate the voltage drop and power across each and every element. For example, I need to calculate voltage drop at 2 ohm resistor. At 2 ohm resistor, the voltage drop V2 ohm is equal to, so V equal to I into R, means I2 into R value is 2. So I2 value is from here. Suppose we need to calculate the power. So power through 5 ohm. So power through 5 ohm is equal to, here also I square R. Power equation is I square R. That is I 5 ohm square into R value. R value is 5. So what is current through this 5 ohm? I3. So this I3 should be submitted here. We'll get the power through 5 ohm. Right? Here is the problem, one problem on KCL and KVL. Right? So we'll go for the next problem. So the second problem, I am taking the voltage source is there, and here I am changing the voltage here. the reverse voltage is applied here. So plus minus 20 volt minus plus 10 volt. This is 2 ohm, 3 ohm, 4 ohm. So in this case also we need to calculate the find loop currents. So we need to calculate the loop currents here. So here also, so first we have to find out the total number of loops in a given circuit. So total how many loops are there here? We are having the 2 loops here. This is loop 1 and this is loop 2. First loop and second loop. Now we need to give the current. We need to give the current directions. So first loop current I am taking as I1, second loop current I am taking as I2. So first loop current is clockwise direction, I am taking as I1. Second loop current also clockwise direction, right? The second loop current also clockwise direction. So here I am taking current as I2. Now what about current through this 4 ohm resistor? That is, here at this node point current is dividing here. That means I1 minus I2, right? Now assign the polarities. So here is the positive. So plus minus, this is plus minus, and here starting from the positive here it will goes like this. Already here we are giving the polarities. Now this is plus and this is minus. Now apply KVL in loop 1 and 2. So apply KVL in loop 1 and loop 2. So now the first loop equation is, I am starting from this point. Now when I am starting from this point, always we need to take the second polarity. So the second polarity is plus, voltage is 20, and at 2 ohm the second polarity is minus 2I1. Here minus 4 into I1 minus I2, that is equal to 0. Now simplify this equation. So 20 minus 2I1 minus 4I1 plus 4I2 equal to 0. Now minus 2I1 minus 4I1 minus 6I1. Minus 6I1 will goes that side. So plus 6I1 minus 4I2, that is equal to 20. Let us take as equation number 1. First loop equation. Now the second loop equation, apply KVL in second loop. Now the second loop, so as per we have to go for the current directions. So I am starting from here. So we can go for the clockwise direction. So here at 3 ohm, the second polarity is minus 3I2, voltage is plus 10, and at 4 ohm plus 4 into I1 minus I2, that is equal to 0. So minus 3I2 plus 10 plus 4I1 minus 4I2 equal to 0. So 4I1 minus 7I2 equal to minus 10. Let us take as equation number 2. Now by solving equation 1 and equation 2, we will get loop currents I1 and I2. We will get these two loop currents. Here is the calculation part of the Kirchhoff voltage law and Kirchhoff current law. Okay, that is Kirchhoff laws. So 2 problems. Now we will go for the dependent sources, right? So dependent source also very easy problems, but we have to more concentrate on the dependent sources here. Okay, so here the dependent sources, I am taking the first problem here. So in this dependent sources, I am taking the plus minus 6 volts, and so I am taking the one single loop first. Now this is 4 ohm and this is 6 ohm and this is 5I. Voltage is V. So this is minus plus. So plus minus plus minus. So now in this problem we need to calculate the V value. Voltage drop at dependent source. Okay, so here we are having the dependent source here. So I am taking only one single loop first. So we need to calculate the dependent voltage here, right? We need to calculate the voltage at this dependent source, right? So here it is a one single loop, right? In this single loop we need to apply the KVL, Kirchhoff voltage law. So here it is a series circuit. In series circuit, what is the constant term? Current is constant. So here I am taking current as I, right? So current through 4 ohm and current through 6 ohm is I only. Now I am starting from this point. So here, so I am starting from this point. So apply KVL. So here plus 6 at 4 ohm minus 4I, and here plus 5I minus 6I equal to 0. Okay, so plus 6 minus 4I plus 5I minus 6I equal to 0. Now simplify this equation. So we'll get 6 minus 6I minus 4I minus 10I minus 10I plus 5I minus 5I equal to 0. Then 6 equal to 5 into I, where I equal to 6 divided by 5, that is equal to, will get 1.2 amperes, right? So in that given circuit the current is 1.2 amperes, but we have to calculate the voltage. So we have to calculate voltage at this dependent source. So already they are given V equal to 5 into I, directly they are given V equal to 5I. So then V equal to 5 into I, that is equal to 5 into 1.2. I is nothing but 1.2. So that is equal to 6 volts. Here is the dependent voltage value. So V equal to 6 volts, right? Here is the one problem. And second one, we'll go for the second problem. So very simple problems these all are. Now the second problem is plus minus 10 volt so this is 3 ohm minus plus 2 VB, this is 2 ohm plus minus VB, and this is plus minus. Now in this problem we need to find VB value. Okay, so same problem, but in this problem the only change is here I am taking the 2 VB, and here at 2 ohm we are having the, they are given hint here VB, at 2 ohm VB is there, right? So now it is a series circuit. In series circuit, what is the constant term? In series circuit, the constant term is current, right? So here I am taking current as I, right? So here we are having the single loop. In this single loop, the current is I. Now see the direction. It is a clockwise direction. So here is the clockwise direction. The loop is clockwise, right? Now in this loop, we need to apply the KVL. So here we need to apply KVL. Now I am starting from this point. So plus 10. So plus 10 minus 3I plus 2VB minus 2I equal to 0. Just I am applying the KVL in this given loop, that is plus 10 minus 3I plus 2VB minus 2I is equal to 0. And here we will take one more element. So 4 ohm plus minus. So minus 4I equal to 0. Now, so plus 10 minus 3I plus 2VB minus 2I minus 4I, that is equal to 0. Now you can see here they are given one hint here. At 2 ohm VB is given, means the voltage drop at 2 ohm is VB. So that means at 2 ohm VB equal to, so 2 into I, where I equal to VB divided by 2. Now substitute this I value in this equation, right? So you will get the VB value. So that implies 10 minus 3 into VB divided by 2 plus 2VB already is there minus, so minus 2I minus 4I minus 6I. So minus 6 into VB divided by 2, that is equal to 0. Now 10 equal to, so 3 into VB by 2 plus 2VB minus, so 2 3s, 3VB equal 3VB. Now 10 equal to, so 3 by 2 means, so let us take as VB as a common term. So 3 by 2 means 1.5 plus 2 minus 3. So 10 equal to VB into, so plus 2 minus 3. Okay, this is minus. This is minus, this is plus, minus, plus. Okay. So 3 plus 3 minus 2, 1. That is 2.5. Then VB equal to 10 divided by 2.5, that is equal to 4 volts. Right, here is the VB value equal to 4 volts. Here is the calculation of the dependent source. So VB equal to 4 volts, right? Here is the dependent source problem. Now we'll go for the next problem. So in this next problem, we'll take the 2 loops. So here we'll take the 2 loops circuit. So here is the third one. So the third problem is, I am taking the 3-loop circuit. So in this 3-loop circuit, so this is 2 amperes. So first we'll take the voltage plus minus 12 volt. So this is 10 ohm, 6 ohm. So current 1.5 Ix, and this is 8 ohm, and this is minus plus V, right? So here in this problem we need to calculate the V value, right? So in this problem we need to calculate V. So find V value. So how we can calculate the V value? So here the problem is based on the dependent source here, right? Here first we have to give the current direction, right? So here I am taking this dependent source here, dependent current source, means, so here also they are given current, that is Ix, okay? So at this node point apply KCL. Let us take as this is some X value, let us take this as a X. So at this node point incoming currents is equal to the outgoing currents. So what are the incoming currents? So this side we are having the incoming currents. So current is going like this, here current is splitting here like this, okay? So now incoming current is 1.5 Ix equal to outgoing currents are Ix plus some Y value. Let us calculate this Y value. So means 1.5 Ix minus Ix equal to Y, where Y equal to 0.5 Ix. So here current through this 10 ohm is 0.5 Ix, okay? Now the polarities. So this is plus minus and this side plus minus, and here also at 8 ohm also plus minus, right? Here is the current direction, right? So current through 10 ohm is 0.5 Ix and current through 6 ohm is Ix, and we are having the dependent source, that is 1.5 Ix, right? Now we need to find out the V value. So we need to calculate this V value, right? So here you can see here is the current source. The source in between these two loops means the circuit belongs to super mesh analysis, right? In this super mesh analysis we need to remove this current source. In this super mesh analysis we need to remove the super mesh current source, means 1.5 Ix current source should be open circuited. Then we can apply the KVL, right? So here apply KVL in bracket super mesh. Now write down the equation. So I am starting from here, plus 12 plus 10 into 0.5 Ix minus 6 Ix minus 8 Ix equal to 0, okay? So plus 12 plus 10 into 0.5 Ix minus 6 Ix minus 8 Ix is equal to 0. Now 12 plus, so 5 by 10, 10 get cancelled, the remaining term 5 into ix minus 6ix minus 8ix equal to 0. Now 12, so minus 8 minus 8ix minus 6ix, so minus 14 minus 9 ix equal to 0. Then 9ix is equal to 12, then ix equal to 12 divided by 9. Now 12 divided by 9 is 1.333 amperes is the current value. Okay, so current through in that given loop. Okay, so now we need to calculate the V value, right? So V equal to, so voltage drop here, the voltage drop at 8 ohm resistor, so V equal to 8 into ix, that equal to 8 into 1.3333, that is equal to, will get 10.664. Here is the dependent source problem. Okay, so you can see here, first of all we need to apply KCL at this node point. So we'll get incoming current is equal to the outgoing currents. So incoming current is 1.5 ix, outgoing currents are, so 0.5 ix and ix, right? So here we are calculated current through 10 ohm, that is I am taking as a y. So where y is equal to, will get 0.5 ix. Now we need to apply the KVL. Now in that circuit we are having the dependent current source here. Now we need to, by using the super mesh analysis, we need to remove this current source, then we need to apply the KVL. Okay, so we'll get plus 12 plus 0.5 ix minus 8 into ix is equal to 0. By solving this entire equation, we'll get the ix value, that is 1.333 amperes. Next we have to find out the voltage here. So voltage is equal to, voltage drop across 8 ohm is equal to, so V equal to 8 into I, or 8 into ix, where ix is 1.33 into 8, so we'll get 10.664 volts. Here is the dependent source problems. Okay, so thank you, Jithendar.